Assalamu alaikum. So the lesson today is about quadratic equations. So we are going to learn today how to solve quadratic equations using factoring method. So the lesson is about factoring method. So the factoring method offer two cases. So first case, so case one is when the constant coefficient equals zero. So if c equals 0 and b is not 0. So in that case, we are going to solve ax squared plus bx equal 0. So here we don't have to use any method we learned before in terms of factoring. So we can use the concept of the common factor. So to solve ax squared plus bx equals 0, so we use the concept of common factor. So we have here ax squared plus bx equal 0. We have x here and x here. That means x is my common factor. So we take x as common factor. So sometimes you can have a and b have common factors. So you can take the common factor of a and b too. Now we know that the product of two numbers is 0 if one of them is 0. This is a property. So a, b equal 0. Then either a equals 0 or b equals 0. So you can use this property. So this is if. So we have either we have x equals 0 or ax plus b equals 0. So now you change it from a quadratic to two linear equations. So this is already solved. So either we have x equal x will be minus b over a, and the solution will be 0. The solution that equation. So I will try to give you different examples. So if you want to solve for 5x squared minus 7x equal 0. So like I say here, I just use the common factor concept. So here I will have x. So we have 5x squared minus 7x equals 0. So I take x as a common factor. So x is my common factor. So I'm going to be 5x minus 7 equals 0. As you see here, we have the product of two numbers is equal 0 if one of them is 0. So either we have x equals 0 or 5x minus 7 equal 0. So as you see here, it's become two linear equations. So the first one is already solved. So I don't have to deal with the first one. So what I do is solve for the second one. So plus 7 both sides. So I got 5x equal 7. Now I divide by 5. So I end up having x equal 7 over 5. So my set of solution will be 0, and 7 over 5. So this is an example. Let's pick another example. Suppose I want to solve for 4x squared minus 6x plus 7 equals 7. As you see here, we have a number on the other side of equal sign, so I cannot take a common factor. So each time we have that type of equations, first simplify the equations, break all the number in one side. So the first thing what I do here, I minus 7 both sides. So I will end up having 4x squared minus 6x, this is cancelled out, equals 0. Now I have 4x squared by 6x equals 0, so I have x as common factor, and we have 4 and 6, they have a common factor, which is 2. So I take 2x as a common factor. What's left is 2x minus 3 equals 0. The product of two numbers is 0 if one of them is 0, which means I will have either 2x equals 0 or 2x minus 3 equals 0. Please don't put and, because some students just put and. No, either one of them is 0. So don't use the word and here. So now here to get x, what I do, I divide by 2 both sides, and 0 divided by a number is 0. So don't get confused on this. Or here what I do, I add 3 both sides. So I got 2x equals 3. Then I divide by 2. So I will end up having x equal 3 half. So my set of solution will be 0 and 3 half. So this is for the first case. For the second case, when we have c is not 0. So for case 2 is if b is not 0 and c is not 0. So in that case, we are going to solve for ax squared plus bx plus c equal 0. So when you end up having the whole quadratic expression or the quadratic statement in one side and 0 on the other side, so the first thing what you do is you do the discriminant. The discriminant will tell you everything to do because we're doing factoring method. So the discriminant will tell you either we use the AC method or we use the direct factoring or use the Ellis method to factor your expression. And again, the discriminant will tell you you have a solution, you have one solution, or you have two distinct solutions. So those are the information you're going to get from the discriminant. So to solve ax squared plus bx plus c equals 0, first find the discriminant of ax squared plus bx plus c. So the discriminant we already know d is b squared minus 4 times ac. So those are the case for the discriminant. If the discriminant is negative, that means you have no solution. Then no real solution. And your set of solution will be empty. You have no solution. If the discriminant is equal 0, so in that case you have only one solution. Then ax squared plus bx is a perfect square. So ax squared plus bx plus c is a perfect square. So you have one solution. We have one solution. And if then you have solution. But what type of fact if it's A is equal to 1 or A is different than 1? You see? So those are cases here. Distinct solution. Uh, what type of factoring I use? Like I say, is depend of A discriminant here for the third case is equal to 1. So in that case, we're going to use direct factoring for my case A. If coefficient is equal to 1, so but still you can use any method of your choice. If D is a perfect and then use AC method to factor, and after that you solve. So C, the last case, if D is not a perfect square, then you have to use Alice method. It is not a perfect square, then use Alice method. Even though Alice method can be used for 3 of them, but those are the choice. So it's at the end, it's your decision which method you want to use. All right, so let's do some example. So I want to factor, for example, that equation. So let's do an example here. Let's start with the. So suppose I want to solve for x squared minus 11x plus 15 equal minus 13. You see, you can have a number on the other side, you can have 0, but the main idea is always bring anything on one side to the other side and keep one side equal 0. So, because this is the setup of the equation. So first thing what I do, I will add 13 both sides. So when we add 13, we will end up having my standard notation of my equations. Now, you see the leading coefficient here is 1. Let me see what's going to be my discriminant. So the discriminant is b squared minus 4 times 1 times 28 because a equal 1 here. So it's going to be 121 minus 112, which is 9. This is a perfect square. So a equals to 1, d is perfect square, so I can use direct factoring. So what I do, I'm going to look for two number p q, so that we have p plus q equal minus 11 and p times q equal 28. So if I use minus 4 and minus 7, you can use the list. So I just want to go fast. If I use minus 4 and minus 7, it will give me 28. But when we add them, it will give me minus 11. So my two value I'm looking for is minus 4 and minus 7. You can make the whole list, but I prefer, guys, that you try to do half of the work in your head to get those answers. So now I know that this x squared minus 11 x plus 28 will be equal to x minus 4 times x minus 7. This is equal 0. So which means that I have x minus 4 equals 0, and we have or it's not and, equals 0, which means that if I add 4 both x equal the solution of that equation. So you see the first thing what I did my district is the perfect square. I know that I can use one of the method, either AC method or direct factoring. I check A is 1, so I can use the direct factoring. In that case, I look for two number P and Q. If I add them, it's giving minus 11, which is B. If I multiply them, it's giving me 28. So you see here, I know if I time minus 4 times minus 7, it's going to give me 28. And if I add them, it will give you minus 11. So I factor this into this. It's going to be x minus 4 times x minus 7. And the products of two numbers equals 0, which means one of them is 0. So I make the first one equal 0, and I put OR. The second one equals 0. Then I did what? I solve for x, which is I use the concept of linear equations. So let's do another example. So suppose I want to solve for this 3x squared plus 5x plus 2 equals 0. So again, I'm going to do my discriminant. So it's b squared, which is 5 squared minus 4 times 3 times 2, which is 25 minus 24, which is 1, and this is perfect square. Now I know that this was perfect square, which means either I use direct factoring or AC method, but I know that A is not 1, so I'm going to use the AC method. So I have 3x squared plus 5x plus 2. So what I do, I time 3 by 2, so I got x squared plus 5x plus 6. Two numbers times together give me uh, 6, and if I add them will give me 5. So those numbers are 2 and 3. If I add those two will give me 5. So now I can factor this. So here will be equal to x plus 2 times x plus 3. But remember, we multiply by 3, so I'm going to check which one is divisible by 3. So this one is divisible by 3. So now what I do here, I have 3x squared plus 5x plus 2 equals 0. I'm going to write down the fraction of this one. I divide this by 3, I multiply the other x by 3, so I will end up having 3x plus 2 times x plus 1 equal 0. So I divide this by 3, I multiply the other x by 3. So to get back to my original statement or expression. Now the product of two numbers is equal 0, which means that either I have 3x plus 2 equals 0, or x plus 1 equals 0, minus 2 both sides. This is regular linear equations. 3x equal minus 2 divided by 3. So x will be equal minus 2 thirds. And here I minus 1 both sides. Then I get x equal minus 1. So my set of solution will be minus 1 minus 2 thirds. So this is for that case. Let's pick another case. Suppose I want to solve for that equations. I want to solve for this 3x squared plus 2x plus 13 equal 17 minus 3x. So like I say, first move all the number in one side to the other side. So I will minus 17 plus 3x both sides. So it's going to be 3x minus 17. Now we'll end up having 3x squared plus 5x minus 4 equal 0. Now I will take my discriminant to see what type of method I will choose. So here I will have 5 square minus 4 times 3 times minus 4, which is 25 plus 48, which is 73. So this is not a perfect square, so I'm going to use this method to factor. So I know that this method tell me that when you add p plus q, you should have 5 over 3, b over a, and when you subtract p and q, you should have the square root of the discriminant over a. Now I solve that system. So here I add to get p, and I put the same system here, and I subtract to get q. So when we add here, I will end up having 2p equal 5 plus square root of 73 over 3, because this is a common denominator. Now I multiply both sides by half. So this is 3. So my p will be equal to 5 plus square root of 73 over 6. Here I subtract. So I will end up having 2q equal 5 minus square root of 73 over 3. Then I multiply by half both sides. So I got my q is 5 minus square root of 73 over 6. Now, this statement will become 3 times x plus p times x plus q, which is going to be x plus 5 plus square root of 73 over 6 times x plus 5 minus square root of 73 over 6, and this is equal 0. So let me this one on another board. Here we go. So I have the side, still we end up having 0. So we have this can be 0 or this can be 0. So x plus 5 plus square root of 73 over 6 equals 0, or x plus 5 minus square root of 73 over 6 equals 0. So this is just one expression, so you don't have to subtract one by one. You can subtract the whole thing because this one is just one number. So I will minus 5 plus square root of 73 both sides. And this minus should be on the same line as the division line or the fraction line, because if you do it above, it's like you're gonna get confused with the minus 5. Alright, over 6. So this will cancel out. So x will be equal to minus 5 plus square root of 73 equals 6. And this minus can be distributed on both of them. So if you don't want to have minus here, so it's going to be minus 5 minus square root of 73 over 6. So this will be my x. And same thing here, I will minus 5 minus square root of 73 over 6 both sides. So this will cancel out. So we end up having x equal minus 5 minus square root of 73 over 6. If I distribute the minus, I will end up having x would be equal to minus 5 plus square root of 73 over 6. And those will be my solution. So s will be equal. So let me do it in a short way. Minus 5 plus or minus square root of 73 over 6. So this those mean that both of them add one uh, one solution. So this is about how to solve a quadratic equations using the factoring method. So I hope guys you got the idea. So please, if you have any comment about the way I present or the way I teach, so do so. It will help me improve my way of teaching. Thank you very much for watching the video, and Assalamu alaikum.